Start the meeting. Well, welcome everyone. Can you see me now, Craig? Can you see a little red dot moving across the screen?
I see that you're recording. Yeah.
Okay. Can you see a red dot underlining the Rochester Academy of Science?
Yes. Yes.
Okay. So everything's moving. All right. So let me start. Well, first of all, welcome to the February virtual monthly meeting. My name is Mark Minerich. I am your host and president of the astronomy section. So welcome everyone. I want to thank Dave Pesch and his company Expudo.com for donating the service, the Big Blue Button. We are we got two more meetings. This meeting and next meeting, we'll have been using this for a year, believe it or not, for our meetings. So it's hard to believe that all this has gone on for almost a year at this point. But this has been a great boon for us to be able to use the service. So I want to make sure I thank Dave and Expudo for their help. So how this is going to work is if it gets noisy, I'll mute you. Please do not be offended. You can always unmute yourself. All you do is just click your little microphone down at the bottom of the screen. It's a little blue thing. And if you're talking, you'll see it kind of expanding in and out. If you have a hot mic or there's a lot of noise in the background, I'll mute you. But please, don't be concerned. Just unmute yourself if you need to talk. If you need to comment, you can always chat if somebody else is speaking. You can chat me directly, or chat in the public chat is fine for questions for the speaker. If you're ever going to be speaking on this, using a headset is the best way to do that, because you can actually decipher all the noise coming in and out. Sometimes you get a little echo effect if you're not using a headset if you're speaking. So keep that in mind. And one more thing, while I got you on this page, if you look up, if the screen is freezing on you, it may mean that you have limited bandwidth. But here's what you can do. If you look at the screen, all the way up on the right-hand corner are three dots that are in a vertical line. The ellipses there. If you hover over that, it says Options. You click on Options, you can go to Settings. And in Settings, you have two choices. You have an Application and Data Savings. If you go to Data Savings, you can, where it says Enable Webcams, you can turn that off. And then what will happen is all the webcams that are broadcasting will not broadcast to you. So it'll save you bandwidth. But you'll still be able to hear everything. You'll be able to see the presentation. You just won't see all the little cameras that are showing in the bottom or the top, wherever you had it set up. For everybody else that is showing their camera, that's a way to save some data and stop the freezing. All right, so here's our agenda for tonight. First, we'll have a welcome, we'll have some announcements. I'm going to give you the state of the section tonight, kind of tell you where we've been at for the last year, what we're looking forward to this year. And then our feature talk is by Carol Higgins, who's with us now. She's a NASA Solar System Ambassador and a Mohawk Valley Astronomical Society member. And she's going to tell us about the James Webb Telescope. That should be going up later this year. All right, with that, is there anybody that this is there besides Carol? Is there anybody here? This is their first astronomy section meeting. Everybody's been here before. Let me look at the list here. I see a lot of usual suspects here. Yep, this looks like a pretty seasoned crew here. So nobody new here. All right. So has anybody been able to do some observing lately? Why I put this picture up. That's what I saw. Clouds. There was a clear night a couple nights ago, but it was so dang cold I didn't even think about going out to do any observing. Thought about doing. I haven't
done anything lately.
Yeah, I thought about doing a star party, and if I do get a night that's forecast, and even if it's cold, I may go up to the 14-inch and try to do a star party, because I can do that in the warm room and not have to stay outside. But more to come on that.
Hey, Mark, I was out a couple nights ago when it was clear and doing some imaging of the Jellyfish Nebula, but I haven't had a chance to process the images yet, so I'll post that on the reflector sometime in the next few days.
Cool. Look forward to that. Oh, so Bill Bill Saline said he saw the ISS pass. Bill doesn't have his microphone on.
Hey, Mark, can you hear me? This is Doug.
I can hear you. Hey, Doug.
I sent you an image of the Orion Nebula when I went out for a nearly full moon hike in the snow last Saturday.
Cool.
And I also did some solar observing a week before that.
Solar observing actually has been available for the last couple of days. We've had some nice sunny days.
Yeah, that's something I want to get into. I want to get a filter for my new telescope.
We had a perfect pass, basically, of ISS last night. It was really cool.
Oh, it's straight overhead.
Straight overhead. Nice and bright. Disappearing into Orion.
Oh, that's cool. That's a cool way to see it. Spotthestation.com, Paul has put up on the chat there. Okay. I use Heavens Above to find it. So yeah, no.
There was a nice secondary satellite too that went across the path of ISS and headed towards Orion's belt.
Oh, that's cool. Were you able to identify what that was?
It was the ESA's satellite ES2.
Oh, okay. Kind of cool. If you observe for any length of time, you're bound to see a satellite or two cross by. Probably easier to see a satellite than it would be to see a meteor. But if you stay out long enough, you'll see a meteor as well. Well, hopefully we have some clear skies and maybe some warmer weather to try to do some observing. And like I said, I'm going to try to get a star party together. I'll have some more on that on the slide here. All right, so it's time to remind you that your membership expired if you haven't renewed in December. And so if you would, this would be the time to renew your membership, as well as key holders. It's time to renew your site key. And that form is at our website, and there's the link there. It's pretty easy to find it on our website. Prefer to have PayPal to do that. It saves actually a lot of time. You don't have to put a stamp on an envelope. You don't have to go to you don't go to the post office, stick it in your mailbox, but still, you don't have to do that if you use the PayPal, and then everything gets there quicker. It is a little bit more to do that, but it's actually safer and a lot easier for us to do it using PayPal. If you need help with that, you can email our membership chair. He's actually our new membership chair, Craig Kaplan. There's his email address there. It's also in the newsletter for if you have any questions on how to do that. All that stuff is available online, or you can certainly contact Craig to help with your membership. Anything else, Craig?
No, I'm happy to try to help anybody I can.
Okay, thank you. You may have heard, you may not have heard, this was actually posted in our newsletter that Gail Shermer passed on January 16th. Most of you know who Gail was. Gail was our membership chair for nearly 10 years. Probably one of the most gentle people you'll ever meet. We thought that we should get the word out to everybody who knew or was associated with Gail at some point during her many active years at the astronomy section. She was always a very friendly, helpful, kind person, and we'll miss her dearly. She actually made a surprise visit, I think it was 2 years ago, to our Rochester Star Fest, and actually helped out doing that job of the picture you see on the right of her counting money. I think she just loved handling money. She being a membership chair and helping out with the registration at Rochester Star Fest. So Gail had respiratory issues, and I don't know if it was COVID related or not, but I guess we could guess that might be part of the cause. But certainly one of the most gentle people that we knew. You might have known her as Gail Smith. Her husband, her ex-husband's name was Smith, but after they divorced, she went back to her maiden name, Shermer. Our best regards to Gail and Gail's family. We certainly missed her when she left, and sadly, we'll all be missing her now. Yeah, she was a sweetheart. Yeah, Bill dealt with her a lot because she handled the paper newsletter distribution as well. You're right. I remember I dealt with her as well doing the paper newsletter. She was a wonderful person. All right, so I left this slide is very similar to the last one, except it's got Neptune on it from our last party, which actually was a long time ago. It was actually in November. So we haven't had a star party, but I will tell you that we have Bob McGovern, myself, and Leo Kellett went to the site a couple weeks ago, and we have refitted the C-14 as a hyperstar, which gives me much more flexibility to do star parties with it. And so as soon as we get a nice night that isn't too awful cold, I'm going to go up and I'll do a star party. I'll let the people know that I'm going to head up there to do that. We'll do a star party. And this time of year, there's a bunch of, I want to say, multiple galaxy areas in the sky that we can look at. So I want to try to do that where we can get multiple things in one field of view, especially with the hyperstar. So look forward to trying to do that in the next few weeks, if we can get some decent weather to do that. All right, so upcoming events, we have a board of directors meeting on Wednesday. So if you would like to attend, the board of directors will all get an invite to that. But if you would like to attend as a member, you're more than welcome to contact me, email me, or give me a note here on the public chat that you'd like to go, and I can send you a link to our board of directors meeting. It's where we plan our events. We plan how we spend our money, what we invest in as far as outreach, all that kind of stuff. Let me know if you'd like to attend. Be glad to have you join us at the board of directors meeting on Wednesday from 7 to 9. Also coming up the next weekend on, is that right? Is that Sunday? Roger? Oh, are you here, Roger? I wonder if I put the wrong date on there.
I got to unmute. Yeah, 13th.
But I believe that's a Saturday, right?
Well, the 13th is the date that was in the.
Yeah, the 13th is correct, but it is Saturday. Just so everybody knows, Sunday is Valentine's Day, so don't come on Sunday. I know that could be it's Valentine's Day. You don't mess with Valentine's Day. So it is Saturday the 13th, and we'll be observing our COVID protocols. I'll review those with you. So those are, if you come to these events that are open house or any other gathering at the Ferris Center, you sign in upon arrival. That way, if we have to, we could trace contacts for who was at the site during those events if there's an active case of coronavirus. And as you do at home and everywhere else you go, you ensure 6 feet distance. You can't be 6 feet apart. Please wear a mask. Generally, once you get to a certain amount of people, and then you pretty much have to wear a mask everywhere you go in there. So be prepared for that. Now, I put in here both bathrooms will be clean, but only one bathroom will be usable because we're on our winter schedule. So that'll be the bathroom downstairs. We could certainly turn the heat up during that day, but we'll turn it back off when we leave. There is antifreeze in the system, so you don't really want to run water in the sink in the kitchen in the bathrooms. So it's really there for convenience if you need to use that one bathroom. The bathroom will be usable. It'll all be sanitized before you go. If you stay for observing, please use red lights to observe outside. So this is an information really for people who are interested in helping out. There's probably about 7 of us involved in a telescope inquiry group. We've met a couple of times. We're starting to get data together for putting together a way that people can address their needs for telescope. We're hoping that as we revamp some of our website, that we'll have a page or pages that will help you to the things of telescope nature, like how to choose eyepieces, how to figure out your magnification, what kind of scope should you look for, and what are the qualities of different kinds of scopes. So a lot of that's coming together, and Pete Botto will be coming to you shortly. We'll talk about it more at our board meeting about how we can start to put some of this stuff together. And we'll actually have some resources for people to use on the website. And then if you can't use that stuff, we'll have a way to contact this group to get help with your telescope. So looking forward to really getting this going. I think this could be a real boon to the people who know about us or of us or have access to our site. And if you're interested in helping, please let me know. I'll be glad to include you in our next group get together, which will probably be in a week or so. Excuse me. Our March speaker is Joe Eakin of Colgate University. He's the technical director at the Hotung Visualization Lab and Planetarium. And what he'll do is he's going to describe what they do at this lab at Colgate University. And it should be kind of interesting. They have a similar projection system to the Strassenberg, although I think they have the latest generation that just came out of Digistar called Digistar 7. So I'm curious to see what they do there. But it looks like they do more than just planetarium type stuff that we do with the Strassenberg, and he'll describe what they do at the Colgate University Hotung Lab. So I'm looking forward to that. That'll be in March 5th. And as spring is arriving soon, whether it's only astronomically, not necessarily in weather-wise, the Messier Marathon should be coming up. And the best couple days to do that are in March. Also a weather risk. So, but Saturday, March 13th is the day that you can catch 110 Messier objects. If you start at dusk and you go all the way to morning, we rarely are able to do that, but certainly we can, if the weather's right, we could do that. If you bring a scope out to the site, you can use a scope that's there. I'll have targeting tools available that you can use to find the Messier objects. And you don't have to stay all night to do the whole thing. You can still have fun. If it turns out to be cloudy or nasty weather, we'll try it again in April, the new moon in April. So that marathon will be on Saturday, March 13th. All right, and now save the date. We do have a date for our Rochester Star Fest. That is Friday and Saturday, August 27th, 28th. Excuse me. We'll be celebrating our 30-year anniversary, and I put an asterisk there because that's what we would have done this past year. But it really is, we will finally be celebrating our 30th anniversary of the Ferris Center at Rochester Star Fest. And that's about the latest we could do it because the next weekend after that would be Labor Day. So we've actually put it as late in the summer as we possibly can so we can actually have a Rochester Star Fest. So looking forward to that happening at the end of the summer. So put the date in your calendars, take your vacation days, whatever you got to do to have that. It's a fun event. And looking forward to doing that. Dave and I are working on actually Dave is working on a speaker for that event that could be pretty exciting to have. But I won't say anything yet, Dave, unless you know something.
Actually, I can confirm him if you like.
Why don't you confirm him? Because that's a pretty cool speaker.
Dr. Filipinko, as in
Alex,
the guy that you see from Berkeley on TV all the time. He owes me a favor.
So Dr. Alex Filipenko, is it Berkeley?
Berkeley, yes.
Of Berkeley will be speaking at our Rochester Star Fest. So we're very much looking forward to that.
Virtually, of course.
Virtually. It's a long way from Berkeley to Rochester. That'll be cool. Yeah, really awesome speaker for Rochester Star Fest. All right, so let me give you the state of the section. I'm going to pull up another presentation here. If I can keep my voice, I don't know what's happening to my voice. I'm losing it. So I'm showing you our annual report. When we pull this together and on the board of directors, we call this the Ferris report. Really, it's just our annual report, but we call it the Ferris report because we do deliver it to the Ferris Foundation and thank them at the same time for their support. They are our largest supporter. Typically, we get about $5,000 a year from the Ferris Foundation, and that's about a third of our budget is what we get from the Ferris Foundation. It's a pretty significant donor for us. So I'll go through this. I'm not going to read word for word what's here. After this meeting, I will send this PDF to Pete Bono and ask him to post it on our website. So if you want to peruse it in more detail, I'll show you what we have done in the past year. So we talk about our observatory out at the Ferris Center and our 17 acres. We talk about our observatories and our membership. A little bit from prior years in this past year, about 232 members that belong to the Ferris, to the astronomy section. So this year we made several improvements. We got a new walkway put in. If you haven't been there, that gravel walkway that was often weed ridden has been replaced with a paved asphalt walkway from the parking lot all the way up to the Wolf Education Building. There's now a shed from the mineral section where they're going to be storing their samples up on the hill on the eastern side of the right against the woods there for the mineral section of the Rochester Academy of Science. The spectroscope is attached. There's actually some work going on there right now. Leo Kellett is leading a crew of people that are doing some spectroscopy with the Meade 12-inch scope there. It's all set up for spectroscopy. And we're actually got a new Pegasus focuser and power unit on our C14, which has enabled us to do a lot of work on with that C14, which I'm going to be using like a workhorse whenever I can use it. So that's a lot easier to use than it was. This Daystar Observatory now has a hydrogen alpha solar scope in it, so we're able to do a little more solar observing besides what we do in the solar building that's right next to this. So several improvements in the Ferris Center. We've had virtual star parties. We couldn't do star parties. As soon as it got warm enough to do star parties, we couldn't do star parties. So we've been doing them virtually. And, it starts out a little chunky getting started doing those star parties, but they're getting better and better. And I'm always up for having company and or suggestions on what to look for the virtual parties. But we have some fun when we review what we saw at the virtual star party. It's better than not being able to do anything. So we hope to do more of these virtual star parties this year as well. Scouts, there were not a lot of scouting events. They only had a couple of scouting events over this past year. And the only festival we were able to do for outreach was the Winter Fest, which was delayed, and then because of weather. And then any other festival that we had was canceled. So hopefully those are something we could do again this year. So our meetings, we went to a virtual format, and thanks to Dave Pesch and Exputo, we've been able to keep up with the meeting like this. So thankfully, it definitely changed how we go to market. We don't meet at the Ferris Center for meetings. We don't meet at RIT for meetings. But we're able to do these, and we have had some in-person events. We've had a couple open houses. We're able to recognize Bob McGovern for his fellow award and retirement plaque. We recognize an astronomer of the year. Thank you very much. That was pretty awesome and shocking. I didn't expect that. But and then we had some actual work parties as well at the open houses. So we've been able to stay safe and meet personally, even if it hasn't been as often or as closely as we've done in the past. And we did have some observing nights. We observed on what would have been the Rochester Star Fest. We had a number of people come in and do some observing. We actually saw Comet Neowise at that event. And we also had a nice observing group at for the Perseid meteor shower as well. So not as often, we're still able to do some of the things that we like to do as far as observing nights at the Ferris Center. The radio telescope, call it autonomous radio telescope. Marty has taken this radio telescope a little bit farther each year, and actually this year it was supposed to come back to the site, but has not because of all the COVID restrictions. But hopefully we can bring that dish back. The telescope will be able to autonomously track and work its way through its paces. I encourage you to read this for more information on what's going on there, but it's pretty cool what Marty has done with the students at RIT and the radio telescope project. We've had a ton of member astrophotography. Here's just a few of the astrophotography that our members have done. And as I said, this is an annual report. We don't have everything in here, but certainly some images of some of the work you guys have done. And of course, our Supernova web page, Dave Bishop has kept that up. How long has that page been in operation, Dave? I caught him on the fly here.
About 20 years now.
20 years. And that's actually how you met Dr. Filipenko, isn't it?
Yeah. In fact, Dr. Filipenko used a number of the images from my page in a number of papers that he submitted, as well as me putting him in contact with amateur astronomers who take a look at supernova. In fact, one of the things he's actually planning on doing is harvesting my page for some data, and he's going to enslave some grad students to do it for him.
As every good professor should do, right? Thanks, Dave. And so we go through about how we communicate. We have our website. We get internet at our website through Frontier. Peter Blackwood does a tremendous job of keeping up our monthly newsletter, giving you guys all that information monthly of what's happening, what's been happening. You have a nice you have a member images section. You get a great report of the coming month in the sky from D on the Owl Light News. We have a nice Facebook page. I think we're about to hit 1,000 likes. So if you haven't liked our Facebook page and you're on Facebook, go like it. We're very close to a significant number of likes and followers on our Facebook page. New in this past year, we started the ASRAS Historical Information Project, AHIP, and Carol's been spearheading this project, is trying to record our history. If you can see in this picture, you can see the nearly complete Wolk building, education building, just as after it was finished. I think that's 1992. Below it, you can see the dome construction of the big dome. And I think that was in the early 2000s. I can't read the dates on there, but Carol is doing a tremendous job leading our crew in getting information from the past and deciding what information we want to save, where to save, how much of it we want to save, and record for posterity, including these meetings, how many members we have, all the different things that we're doing for outreach. So she's doing a tremendous job of pulling all that all together. That's a job. That's a real job. Carol, anything you want to say about that? I caught her off guard.
Mute. Okay, there we go. Sorry.
It's okay.
Just if ever
We lost you.
that might be really useful to that. I mean, the primary focus is the last 40 years. And, so if you have really special pictures or documents or memories you'd like to share, get in touch with me. Let me know what you have, and we can decide whether we can tuck that into the official archives, or maybe that'll go in the second level archives. Okay?
Great. Thanks, Carol. Appreciate all the work you're doing in corralling all these people to do this. It's been a bang-up job.
Thanks.
And then we record what our achievements are for the year, and then what we're looking to do for the next year. So we were able, despite it all, to have 14 member events, and that includes these virtual meetings. We've had 6 observing events. We've had 9 social events, and most of those have been open houses and work party kind of things. And we've held board meeting every month. We've had virtual star parties. Typically for scouting events, you see 4 there on that list. We're typically somewhere between 25 and 30 scouting events at least during the course of the year. So that's really curtailed a lot of our ability to do outreach, is not being able to have these guys meet. And some of our scientific achievement areas have been in the website, the Supernova website, and the radio astronomy. What we've done, I talked about, we did the asphalt walkway from the parking lot up to the Wolf building. We removed a dozen trees that were presenting hazards to buildings on the site. So that's improved viewing. Spectroscope was attached to the in the Urles building, and now we can start doing spectroscopy in that building. And the primary imaging scope, the C14 in the big dome, was fitted with a new focuser, and that actually is a nice way of being able to handle the focuser, the electronic focuser. So for 2021, what we'd like to do, if the Rochester City School District ever gets back to meeting again, we'll provide some classroom experiences for students. But right now, that's pretty much on hold. There's not a whole lot we can do with the Rochester City School District until they can really get their students back. We're in the process of forming we actually formed a telescope inquiry group. Glad to have more members of that, and I hope that this can be a pretty strong group and outreach tool to virtually or in person help people with their telescopes and with their choices with telescopes and using telescopes. We want to add some crushed stone to the driveway. We want to add solar powered ventilation to some of the observatories. Some of them get very hot, so if you're going to use them in the summertime, it takes a long time to cool them down. So we'd like to add some ventilation. And if it's solar powered, it's pretty much free to run those things to ventilate. We want to upgrade the security. We have cameras at the site all over the place. They're taking still shots on a regular basis, but we like to be able to upgrade that security system with a regular server. We got some stumps from the tree trimming in the fall that we're going to remove. Actually, Roger's working on that. That'll be done this spring. And then we want to be able to actually do some scientific work with the spectroscopy observatory that we've got going, and then implement more of the, continue to implement the radio telescope projects that Marty's doing with our IT students. And then we'd love to be able to do our full spectrum of educational and outreach programs. I'd love to see us get back to doing our science club this fall for students of 11 to 14 and any age beyond that, but we'll gear it to that age level. And anybody else that wants to participate certainly can participate. We'd love to be able to do that, but it's really a matter of when we can meet again. So that's up. That's our year. And as I said, I'll send this to Pete Bono after the meeting to put up on our website so you can peruse that at your leisure. All right, with that, I give you to our feature presentation by Carol Higgins. So Carol, I'm going to make you the presenter, and then you can share your
okay.
Share your.
I will do my best. So I need to take it and click on my screen. Can you see my screen?
Not yet. You need to share your application window.
Okay, hold on a sec here. And that was
the button all the way over on the right on the bottom.
Share my screen. Sorry about that. Yes.
Yeah. Or share your screen or share your application window.
I'm going to select my window.
And then confirm. There you go.
Oh, okay.
You're on. Perfect.
Oh, okie dokie.
Right. I'm going to turn off my camera.
Okay. Thanks, Mark and everyone, for inviting me. Tonight we're going to take a look at the James Webb Space Telescope, which is going to launch later this year. The topics we're going to cover include mission goals and what are the science projects and things they're trying to achieve with this mission. We'll be taking a look at the telescope and all the instruments that are on board, where it will be in space, and then we'll take a little status report, take a look at where we are right now and what's going to happen as we get closer to launch, what happens after launch, and give what the current status is of the project. So let's start with mission goals. The discussions about a telescope system, a space telescope system like James Webb, got underway in the early 1990s. There was a lot of discussion and a lot of people putting input, and eventually this huge wish list came to be. And as I got closer and did some designs and, okay, what can we do and what seems too hard and not worthwhile, finally they decided on some very specific mission goals, and they tried to figure out a way to organize everything. So they came up with 4 goals and the science themes that are associated with those goals. So the very first one has to do with the early universe. So if you look at the picture on the right, on the left-hand side of it, you see the Big Bang event. And then there was some things that happened after that. But then all of a sudden, we believe that there's a period of time where we entered kind of a dark phase. And that went on for a while. And then all of a sudden, about 400 million years later, things started to happen. So all of a sudden, stars started to form. So some of the questions they're going to try to answer, because of the technology that's on James Webb, what they're going to try to answer are things like, okay, well, when did those stars really form and what did they look like? Eventually, galaxies were born. So there's a lot of questions about the early universe. We haven't really had technology available to us to be able to answer some of those questions. So we're hoping that James Webb will do that. The second set of goals, it has to do with galaxies. And what they're hoping to shed some light on is how galaxies evolved. So how do they actually form and what gives them their shape? We know that there's a lot of different types of galaxies and shapes and so forth. So I'd like to get a little more knowledge about the formation of galaxies in general and what is in them. What are the elements that make up the components of the galaxies, and things like other questions like, well, what happens when they collide or merge? The Whirlpool galaxy is one that we are all familiar with, and that's a really good example of 2 interacting galaxies. The third goal has to do with stars, and one of the famous places that we know about, what we are referring to as a stellar nursery, is the Eagle Nebula, the Pillars of Creation, and that very famous Hubble shot that got everybody all excited. So there's clouds of gas and dust in there, and so how does all that stuff, how does all that material eventually form stars? So we're going to try to get some insight into that. How do they evolve, and at the end of their life, and they blow off material or whatever happens to them, what happens to that material? How does that get recycled into stars or potentially planets? So and we want to try to understand, because a lot of stars seem to have some kind of planetary system around them. We want to try to get a little more insight into that. So next, and the final goal has to do with planetary systems. And so our solar system is a planetary system. So what we're going to hope to learn more about is how are planets formed? How do planetary systems evolve? So, it's one of the things that we're always, from our viewpoint, we believe that you have to follow the water if you want to try to understand whether life exists on planets, or if there's potential for life, or if there isn't, then what happened to it. So this whole segment is going to be based on planetary systems, and we're actually going to take a look at our very own solar system as well as exoplanets. And as you know, lately there have been a lot of discoveries of exoplanets, so there's a lot of exciting science that can be done using the James Webb Space Telescope to try to understand them. So the telescope is named after, there really was a guy named James Webb, and he was the second administrator of NASA, and he was the guy in charge during our early space program. And so Mercury, Gemini, a lot of us are familiar with those programs, in Apollo. And one of the things that kind of set him apart and made people really appreciate him, especially as time went on, was that he was a real believer in science. So if you remember back during the Mercury and Gemini and Apollo programs, and in particular Apollo, we were in what was called the space race. So we were kind of in competition with the Soviet Union. And so a lot of people were like, oh, let's go to the moon. Let's just beat the Soviets and say that, okay, hey, we went there. But James Webb didn't really feel that way. He was like, oh yeah, let's go to the moon. But when we get there, what are we going to do? Are we just going to land and then take off? So he was very insistent on having a strong science program. And today, you know, we can't imagine having a space program or a mission without science, right? So it seems like there's a lot of wisdom that was in the decision to name the telescope after him, because he was a real believer in science. So the telescope, this is just kind of a general overview of the telescope and the instruments on board. The telescope is an infrared telescope. It's really big. It's the largest telescope and primary mirror ever launched into space. And as astronomers, you know, there's always the joke about, oh, we need more light and we need a bigger light bucket. Well, they really would like to do that. If you're going to build an infrared space telescope, gee, let's really go for, you know, the high end here. So, but the problem is, okay, you can build one of those things here on Earth, but how in the world do you actually launch it into space? And with the rigors of a launch, you've got some real technical issues, because it is not easy to launch anything into space and escape Earth's gravity. So they came up with a really novel idea of, okay, well, we want a big giant mirror, but let's figure out a way to fold it, and let's figure out a way to fold the telescope and everything that goes along with it. So in the upper right, that picture, it's an illustration of what Webb will look like in space. But the reality of the thing is, on the very right, that's a picture of that whole big ginormous telescope folded up and put inside of a payload fairing. And so that's an illustration of, for real, of what the telescope is going to look like packed in the in that fairing. So like all telescopes, it's a time machine, but it's going to look back further in time than any telescope or any equipment that we have. And it's going to be out in space 1 million miles from Earth, so it's not going to be serviceable. And so we're going to talk about that, its place in space, in a little while. It has sensitive instruments, and because of the location where it is going to operate in cryogenic conditions. So it's going to be really cold, and all of the instruments and everything on board has to be able to live and function in that environment. So the difference between basically visible and infrared is illustrated in the pictures in the bottom there. On the left is the famous Pillars of Creation, the Eagle Nebula. And on the photo on the left is actually a Hubble shot. And the picture on the right is also a Hubble shot, but it's in infrared. So as you can see with infrared, it's almost like you can lift the veil of the sort of a curtain of the gas and dust and so forth, and look beyond it. So it really gives you a different perspective of what the object looks like. And Lagoon Nebula is another. There's another example of visible light on the left, and what that same object looks like in infrared. And one of my favorite little when people say, well, how powerful is this thing going to be? There was a guy, John Mather, Dr. Mather, who is actually the lead project scientist of the James Webb Telescope, and he was on a Twitter exchange a while ago, and people were asking him questions, and someone asked the question, well, how powerful is this thing going to be? So his response, his tweet back was, James Webb can see the heat signature of a bumblebee at the distance of the moon. So that gives you some perspective, because boy, those bumblebees are pretty dang small. So one of the things that's really super exciting about Webb is the new inventions that they had to come up with to achieve these science goals. And there is not much on that telescope that's off-the-shelf stuff. They had to really dig deep and do a lot of interesting engineering, solve a lot of engineering issues, and just all kinds of things. So there's micro shutters. That's they look in the picture, they look big, but that's a way for them to program whether a shutter is open or closed to let light through to the detector. And there are a series of 4 of them on one of the instruments that's on board, and the total number of those micro shutters is 250,000. So there's 250,000 of these micro shutters that are covering the detector arrays, and you can they're programmable, so they can open and close them, which really is that's really a new technology that is really going to make a big difference in the ability of what they can observe. Cryocoolers have to do with keeping the telescope and all of its components at cold operating conditions, constant temperature. The backplane has to do with the structure of the primary mirror, and it's basically the bones of the telescope that holds up the primary mirror, and we'll talk about that. The mirror itself is a series of components. We'll talk about that, and a lot of integrated circuits. Because of the cold conditions, they had to invent new integrated circuits. A sun shield. There's never been anything with a sun shield, and because it's protecting the telescope from the sun, they had to invent new technologies to protect the sun shield itself, the material. And then there's infrared detectors got invented. There's wavefront sensing software. So just the list goes on and on. So the spacecraft itself, it's a spacecraft / telescope, and the big gold thing, as you would know, is that's the optical telescope. So this is the primary mirror in the center. The secondary mirror, I don't know if you can see my pointer or not, but there's the tripod boom sort of thing. The secondary mirror is on that platform, and of course the light comes and hits the primary mirror, bounces back up to the secondary mirror, and then it goes through that black I don't know what the heck it's even called, but anyway, there's an entry in there, and behind this telescope is where all the instruments are to collect that light and do something with it. So the back plane is the thing I was mentioning, the skeleton, and again, we'll talk about that. The instruments are all directly behind the primary mirror. There are 4, so this is called the Integrated Science Instrument Module, or ISIM. And that whole module has 4 instrument packages back there. So there's a mid-infrared instrument, near-infrared spectrograph, near-infrared camera, and then there's another whole system that has to do with fine guidance and making sure that the telescope is properly aligned and pointed in the direction it's supposed to be pointed in. And then there's below that is the sun shield, and the sun shield and the stuff, all that stuff below it, is called the spacecraft element. So below the sun shield is basically the bus of the telescope, and in there is all of the communications and electronics and propulsion and so forth. So let me give you an idea. We're going to talk about all of those elements, but let me give you an idea. I'll set it in motion just so you could kind of get a 3D view and spin it around. So the instruments are in the black part there up on top. All the bus and everything is below the sun shield. This is where the instrument package is cleverly tucked away and protected. So it's pretty complex and quite an interesting design. When trying to compare the mirrors on some of our favorite telescopes, so we've got Hubble Space Telescope and Spitzer. Spitzer was an infrared telescope, but this will give you an idea of the light collection abilities and the size of the mirrors. So the illustration on the left shows the size of the Hubble mirror, not quite 100 inches. Spitzer was only 33, but the Webb is 255 inches. So basically the Hubble is a little over 7 feet wide, and the James Webb mirror is 21 feet. So there's quite a size difference. The picture on the right shows how, this is kind of one of my favorite pictures of relative size. So that's the whole mirror, the whole primary mirror splayed out and getting ready to be placed into one of the vacuum chambers for one of the environmental tests. But all those little things down on the floor, those are all people. Those are all the technicians that were working on the telescope. So it really gives you an idea of the size of the thing compared to people. So the mirrors, there are 18 mirror segments in the primary mirror. So if you look up in that picture on the right, you can see it sort of looks like it's a honeycomb design, right? And there are 18 of those mirrors, each of them, and they're hexagon shaped, and each one of those segments is made from a material called beryllium. And beryllium was a good choice because it's very strong. It's more rigid than steel, but the best property about it relative to the strength is it's very lightweight. And each one of those segments weighs 46 pounds. So that isn't really very much They're 4 feet 3 inches in diameter, and as you know, anything that's going to be launched into space, every ounce counts. So they had to be, okay, you want a big ginormous mirror, but you can't have one of the traditional kinds of mirrors. They had to really get clever to come up with this design. So each one of the segments is coated with gold, and gold has proven to be the best reflector of infrared light. So when that light comes in, it's you get not much degradation at all. And the interesting thing about the gold is the layer is only 1,000 atoms thick. So dang, that's really they're like super duper shiny, but that's a very thin coating. So that's pretty impressive. If you look on the left, this is the back side of, so obviously the shiny side with the gold that's all polished and so forth, but the back side is interesting. So to save weight, they decided to machine out some of the material, actually get rid of some of the material so that it reduced the weight of each one of those hexagons. So that was quite an interesting design challenge. And so the honeycomb shapes worked really well for that, and it still maintained its integrity and its strength. But each one of those mirror segments has they call it a hexapod. So that's that 3-sided unit, and at the end of each one there's actuators, so they're little motors, and they can flex the mirror in different directions, and they also can be made to push and adjust where the actual mirror segment is positioned, so they can snug it over closer to the next one over. So anyway, there's a lot. They have a lot of control over the mirror segment, and of course, you need electronics. So they need to be able to talk to each individual segment when they're doing some alignments and so forth. The back plane is super important, and this was another interesting technological and engineering challenge, because they need to be able to actually fold the mirror. You can't have all 18 of those segments in that big roundish shape. If you look at the picture on the right, the back plane is basically it's the holder of each one of those mirror segments. And if you look to the right, there you'll see a series of 3, and if you look on the far left, you'll see a series of 3, and those are like wings, and they actually fold down so that the mirror will fit in that payload fairing. So that was kind of an interesting way to do that. And the picture in the middle shows it actually folded up with the wings tucked in next to the sort of the center point. So the importance of the backplane is it has to hold all those 18 mirrors. It holds the secondary mirror support structure, so that triangular, the 3-sided tower, and all the science instruments. Again, behind the telescope itself, the mirrors, is where all the instruments are. So there's about 2.5 tons of hardware that backplane has to hold up. So it's kind of like the skeletal system, right? It's got to be really tough, and it's got to be, when they're out in space, that thing has to be rock solid. It can't move around. It can't flex. It has to provide the thermal stability. It can't be, expanding and contracting and so forth, because as we all know, as astronomers, you don't want your telescope moving for any reason. So they came up with a material, graphite composite, and they had decided to use titanium and invar fittings because those materials also are known for not much thermal expansion. So it was quite genius, I think, the backplane. The science instruments, again, the science instruments are behind the telescope and the primary mirror. And there's, as I mentioned earlier, there's 4 major systems, and they're enclosed. If you look on the right, the illustration, they're enclosed. All the instruments themselves are in the kind of in that cage. That's where the instruments and all the subsystems, there's detectors that go along with each one of the cameras or spectrographs and so forth. There's filters and there's electronics and all kinds of good stuff. So all the primary hardware is in that upper section, and below that there's that little orange section, and that's where all the electronics are and some of the thermal control components and electronics and so forth. So and below that there's some coolers, cryogenic compressors and so forth to keep the electronics at the right temperature. The spacecraft part, so again, that's the sun shield and all the stuff below it. All of that is the sun side of the James Webb. It's going to be in constant sun. It's never going to be eclipsed by the sun or by the Earth or anything. So it's going to be in direct sunlight all the time. So underneath there, underneath the sunshade, is a solar array, and I think it's got 5 segments. It has to fold up and be deployed as well. But it's basically 20 feet long, generates 2 kilowatts of power, and all the systems, all the electronics on board Webb apparently only are going to use 1 kilowatt. So we've got a little cushion there in case things degrade over time during the mission. There's a high gain antenna so that there could be communications between mission control and the telescope. And below on the left hand side there, if you look in the middle, there's kind of like a square box, and that's the spacecraft bus. And inside of that are 6 subsystems. So that's where the solar power panels, all that power gets put into the electrical power subsystem. There's with all the feeds up to the instruments and so forth. There's attitude control for steering. There's reaction wheels and so forth, so they can move the whole thing around. There's communications again with Earth. There's a computer on board, so that they can take the data. We can basically download the data back to Earth, and from Earth we can upload commands. Okay, here's your next observing targets and so forth. So anyway, that's what the computer's there for, and plus monitoring, of course, all the systems. There's a propulsion system, so with some little rockets, little engines under there, and there's a thermal control subsystem. There's also 2 in the front of the bus. You probably can't see it very well here, but there's 2 star tracker telescopes, so that they can make sure that they're pointed in the right area, and there's 2 of them, so for redundancy as well. And this is kind of an interesting thing, because the sun shield is so large, and because the sun is solar wind is pushing against it all the time. It's kind of like a big sail. So the solar wind actually is going to be putting some pressure on the sun shield. So this little trim flap in the left-hand side, it's kind of like a boat, and they can move it up and down, and it actually will help to balance the pressure and keep the whole telescope and everything stable. So that was kind of a cool thing to learn. I didn't actually realize that. The operating temperature on the sun side, again, in constant sunlight, so everything's going to be around 230 degrees. So it's going to be pretty toasty under there, which brings up the importance of the sun shield. If that sun shield does not work, then there's going to be direct sunlight on the telescope and the instruments, and infrared, of course, that's the kiss of death. So they have to rely, and they had to come up with some really novel ideas of how to protect the telescope. So they came up with a sun shield idea, and what it is, it's 5 layers separate. And if you look at the picture on the right, you can see there's actually space in between each one of the layers. So the bottom layer in that picture, that's what the sun's going to be hitting all the time. And then with each subsequent layer, it's going to get cooler and cooler. So there's not going to be any heat radiated up from, as you get to the top layer, there won't be any heat radiated up toward the telescope. So one of the challenges was, okay, so that's a cool idea, but now how do we accomplish that? And they had a lot of trouble trying to come up with some materials to make sure that the structure stayed strong and didn't tear. So they came up with a way of having a continuous roll. Each layer doesn't have seams in it because seams come apart. So that was another challenge. And they wanted to protect the sun shield, so they came up with some coatings. Captain is a good one. So it was really quite another one of those engineering feats. But the interesting thing is the sun shield has to be folded up, and we'll talk about that in a while. So pretty interesting challenge. The sun shield itself is about, when it's fully deployed, it's about the size of a tennis court. It's 46 feet wide, and it's almost 70 feet long. So it is big. So this is just kind of a fun reminder that on the sun side, that's what's going to be pelted with solar radiation, and on the cold side, there's quite a temperature difference between the hot side and the cold side. So where is it going to be in space? Well, it's going to be in the L2 Lagrange point, and L2 is 1 million miles from Earth. And the reason for putting it out there is it's going to get a really good clear view of deep space. And when it's in L2, it's not going to actually sit in L2, it's going to actually orbit around L2. And it's going to take 6 months for James Webb to make one complete orbit of L2, and that's called a halo orbit. So the cool thing about the Lagrange points, and this one in particular, is that they don't have to carry a lot of fuel on the spacecraft, although there is fuel and there is a way to propel the spacecraft for movement. The gravitational pull balance that you get, the free ride basically from the L2 position, was a really great advantage to cut down on the amount of fuel that you need. After launch, it's from Earth to the L2 point. It's going to take about 30 days for it to fly out there and begin its orbit. And on the way, it's going to do some trajectory changes because it has to, you can't just shoot it at L2. You have to slowly tweak the trajectory so that it'll go into orbit. And once it's there, it's going to take all total from launch to commissioning, getting the spacecraft and all the instruments up and running. It's going to take about 6 months for the science mission to begin. So I'm going to show a video, which I apologize, it's supposed to have audio, but I'll try to explain what's going on. This is trying to give you a visual of what parts of the sky is the telescope going to be able to observe. So there's the sun in the middle, and of course Earth and our little moon, and there's going to be James Webb out 1 million miles out. So again, the mirror's perpendicular to the sun. And so therefore, we have to be really careful with those movements. You can't take a chance on moving orienting it so that the sun touches anything. So it can only move side to side a very short area, but it can actually do a 360 of the sky. So as it orbits the sun, as just like in our night sky, the things that you can see will change. So all of the observations that are going to be made have to be planned far in advance so that as we get to those points in the sky, the observations can occur and then it can move on. So again, it has access to the entire sky in that 6 months, and then it can start all over again. So here's kind of a cool visual of what how it's going to work. Okay, so what's going on and what's next? So 2020, as we know, was quite the year, and it really messed up a lot of schedules. But they still found a way, the team getting Webb ready, found a way to continue with the testing, because we have to do everything we possibly can to make sure that this thing is going to work once it gets out in space. So you just test and test and test again, and if you're not too sure about something, you test it even then again. So they've put all the instruments, the whole configured telescope in cryogenic testing and vacuum chambers. The picture in the middle on the top is actually the telescope folded up like it's going to launch. So this is really the launch configuration. And that little ring down on the bottom, that's actually how the telescope is going to be mated to it's the adapter to hook it to the rocket. So anyway, this is a picture back in early fall, I believe it was, where they were going to take the telescope and put it into two different test chambers. One of them was to blast it with sound waves, and the other test had to do with vibration. So, shake it. And basically, both of those tests were to say whether everything could survive launch, because launch is a pretty violent, at least in the beginning. It's shaking and rocking and rolling, and there's a lot of sound going on. So they were simulating what Webb was going to be subjected to during the launch, and everything went well. So that was a good thing. They've tested the solar arrays to make sure the power generation is spot on and everything was good. In the lower left corner, they actually deployed the sun shield. So here it was folded up right after the acoustics test. Everything, the sun shield actually gets folded up into this little tiny, well, not really tiny, but small volume. But in space, once it launches, they're going to have to deploy the sun shield slowly. There's arms and there's actuators, and it's going to take quite a while for that to happen. And once it opens up, they have to make sure it's taut and at the right tension. So anyway, that test actually finished in December, and everything went really well. So keeping fingers crossed that we're in good shape. And the picture on the far right is, again, another picture of James Webb in the launch configuration, and you can see a better view of the sun shield all folded up in these the pink side panels. This is a kind of okay, where are we in the big long line of things to do? So the whole environmental testing is complete now. So far, I haven't heard anything of any problems. It looks like everything went really well. We're down into the center section in this chart, and I know for sure that the tower got deployed and the sun shield got deployed, and so now they're sort of in the center part of that where they have to fold everything back up and basically get it ready for launch. And once all the testing and all the boxes are checked and everybody gives it the amen, we're ready to go, the thing will be prepared for shipping and get ready to be sent to the launch site. And it turns out that James Webb today, right at this very minute, is in California, in Redondo Beach, where the Northrop Grumman site, where they're doing all this final stuff. And it's going to be transported to the launch site by barge. And we'll talk about that in a second. So the launch of James Webb is going to be from a European Space Agency launch site in French Guiana, and that is a site that's in the kind of the northeastern corner of South America. And apparently they could have flown it there, but the airport is so far away from the launch site. It has to go over some bridges to get there to be transported by truck or whatever, and they didn't want to take a chance, so they're actually sending it on a barge through the Panama Canal and to the launch site, which is very close to the Atlantic Ocean. So it's currently scheduled for October 31st this year. So we're going to keep fingers crossed that's going to happen. So I wanted to just do a quick talk, mention COVID and what impact COVID had on this mission as well as all the other NASA missions. There are 19 centers in the NASA family. And when COVID struck and everything had to shut down, everybody was at stage 4. That means everybody has to stay home, telework, and all the facilities shut down except for certain mission essential personnel were allowed in. So places like Johnson Space Center, where they manage the International Space Station, you can't say, oh, well, we're going to have to shut down, guys, you're on your own. Nope. They found a way to safely get people in and out and so forth. So James Webb was impacted by that significantly, and that's part of the reason why the launch got shifted down to October. It actually was going to be much earlier this this year in March, I believe it was. So right now, every one of the NASA centers is currently still at stage 3, which for the majority of people is everybody's working at home. You have to, they are still allowing people on site, but again, mission essential and mission critical work, and it has to be approved. So James Webb was one of those projects that they found a way to get a smaller workforce, but nevertheless, they managed to continue working. The Perseverance rover, same kind of problem. The Hubble Space Telescope is up there, so those folks have to be able to manage those missions. So anyway, we're still a long way from everybody going back to work, but I just wanted to share with you that that's when you stop and think about all the impacts on some of the space missions, it's quite significant. So once James Webb is launched, who has control over it? Well, it turns out there's a group in Baltimore, Maryland, called the Space Telescope Science Institute, or STSCI, and that's the group that manages and does all the work for scheduling and downloads of data of the Hubble Space Telescope. So they've been long in the queue because they do such a superb job. They've been long in the queue for doing the mission control for James Webb. So part of the impacts of COVID was they actually had to reconfigure the work, where mission control is. So, putting up partitions and all that stuff to keep the workforce safe. But that really and of course, not everybody could come in like they normally would. So that really impacted the testing that went on for James Webb. Because part of the testing had to include mission control. You have to make sure that the computers and all the comm systems between mission control and the telescope work. So they still did lots of rehearsals. They found a way to quickly get that site reconfigured and, got people in that they needed. So all that work was done. So, kudos to everybody who figured that all out. Again, when Webb launches, it's going to take about 6 months for it to get out to the L2 site, and on the way, it's going to be doing a lot of deployments of the instruments and so forth. So it's going to take 6 months before science begins. And once the mission is underway, this group, the STSCI group, is going to manage all of the scientific requests. So if you want to submit your proposal for, hey, I'd really like to look at the blah, 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 and here's why, you submit it through this to this group. They're the ones who also do scheduling and program all the observations that are planned for the telescope. They do flight operations, make sure that, sort of health checks and so forth. And they're also the place where when data is returned back to Earth from the telescope downloaded, they're the ones who grab the data and put it in a repository, and then they dole the stuff out to wherever it's supposed to go. So they have a big responsibility. This is just a quick overview of what's going to happen from launch all the way out through the commissioning operation, the 6 months. So on the left in the center, there's the orange thing, and then the green area, and then the purple area. So if you start on the left, SC commissioning, that's spacecraft commissioning. So that's where the launch occurs, way on the left-hand side. So right after launch, if you look up a little bit, LV-SEP, way up at the top, up above that first little pop-up thing there, says L+30 M. Well, that's launch plus 30 minutes. So that means that that's the point where the James Webb Space Telescope is going to detach from the second stage of that Ariane 5 rocket, and it's going to be on its own headed toward L2. So that's going to take about 30 minutes for it to separate, and 31 minutes after launch, the solar array is going to unfurl, and because they need to start generating power, and a couple other things get deployed, the comms system, the communications antennas, all that stuff gets all squared away and make sure we can communicate directly. So immediately, so this, again, back up at the top, the MCC 1A, that's a mid-course correction. So it's not going to take very long. They're also already going to have to change the trajectory a bit so that they could start tweaking that trajectory to L2 to get it into that halo orbit around L2. So anyway, SC commissioning, that is where the origami telescope begins to unfurl, and there's this long dance of, it's going to be very slow, but it's going to take 30 days for that to happen. And there's a really cool video that's an animation of what that's going to look like, and the video is 12 minutes long, so you can get an idea of how many. There's hundreds of steps that have to work. So anyway, but they're going to turn on some of the instruments, make sure that they can actually turn them on. And then after that first 30 days, you know, the telescope is all stretched out and looking good. And we've talked to a couple of the instruments. And then everything, as we're again heading out in L2, it's cold out there, so the telescope's going to cool down. We all know how important it is for everything to cool down, right? During this OTE commissioning, this is where the telescope alignment is going to happen, where all the mirrors are going to be adjusted. They're going to do more testing of some of the instruments, make sure that all those things are working. There are some things they can't do until it gets down to certain temperatures. So there's a lot of things going on for the next couple of months. And then once you get into the purple part, this is where SI is science instruments. And this is where we're actually going to talk to every one of those primary instruments, turn them on, make sure they're working just fine, and then at the end of that, if you add up all those days and all those months, we've taken 6 months to do that. And that's, if everything's okay, that's when the science mission will begin. So this is a video that gives me anxiety to watch it if you've ever collimated a telescope, but this will show you what they have to go through during that commissioning phase. So that video was done by Goddard. And if you'd like to see some really cool videos, just Google Goddard and James Webb, and there's just a ton of really, really cool little educational snippets like that. So this chart is just a quick overview of what they're going to do in the beginning when the science mission begins. They've already got 133 programs locked in of what they're going to be observing, and this is how kind of a good overview of how what they're going to be looking at. So first galaxies, exoplanets, and so forth. They've also, back in November, people who wanted to submit proposals for observations, there was a deadline that you had to do that. So apparently that's been completed as well. Some of the targets they're going to look at first are a lot of deep field stuff, certain galaxies, stars, exoplanets, TRAPPIST. That ought to be really interesting to learn more about that planetary system. And but we're also, in this first set of targets, we're also going to look at our very own solar system. Some of the gas giants, and what's not on here is Pluto. I guess Pluto's later, but anyway, we're going to take a look at our own solar system. Webb is an international collaboration, over 120 universities and organizations and businesses, and lots and lots of people have been involved. Within NASA, these are the key research centers that provided some either technology or facilities or instruments. ESA is European Space Agency, so they're involved big time in the project, just like they are with Hubble, and they provided some spectrograph stuff, and they're the ones providing the launch service. CSA is Canadian Space Agency, and they've worked on the Find Guidance sensor, which is really important to make sure the scope stays pointed where it's supposed to be, and some other stuff, spectrographs and so forth. The primary contractor is Northrop Grumman, and they're responsible basically for putting all the pieces together, the spacecraft bus and the sun shield and so forth. So they've played a major role, and again, that's where Webb is right now. It's in a Northrop Grumman facility. And then, of course, the STSCI is the mission control. So this is just kind of a fun little nod to all the people and all the agencies and universities and so forth that have been involved in the project. And I wanted to point out the New York State. So in Rochester, there are quite a few companies, including the University of Rochester, that were involved in various phases of the project. So it's possible that maybe some of you know some people that had something to do with it. So anyway, that's kind of a fun little factoid. So that's all I have. If you're interested in learning more about the James Webb and also about the current status of things, the JWST NASA.gov is the main NASA website, and the Webb Telescope site, the webbtelescope.org, that's the STSCI website, and they've got all kinds of really interesting technical information for folks that are well versed in spectroscopy and so forth. So that's all I've got, and if anybody has any questions, I'll do my best to answer them.
Thanks, Carol.
You're welcome.
I have a question from Don Chamberlain, who asks, what propellant is used for maintaining attitude or adjusting?
Well, there's a series of things. There's reaction wheels to help rotate it. There's a couple of gyros, and they're not the usual gyros. They're called HRGs. And if I'm remembering, I think it's something like hemispherical resonator gyros. So they have no moving parts. It's more sound waves, basically. And there are the fine guidance, there are engines. I believe there are 8 small engines underneath, so that if they need to propel. Actually, when the Webb is, there's 2 sets of engines, I guess you would say, with propellant in them, and one set is used for getting the spacecraft out to L2. And then the other ones are making adjustments to moving the thing around. So the fuel itself, I can't quite remember what the fuel is, but it's there's not a lot of thrust because you can't really move it quickly. There are little bursts of stuff, but I believe there are I believe there's either 6 or 8, but I think there's 8 small engines, and they're down by the bus, underneath.
Mark High here asks if any of the images that are captured are going to be released to the public to see.
As far as I know, they are. Kind of like with Hubble, though, like the Juno mission, right? Juno mission, that was one of the things that the Juno mission to Jupiter, they wanted people to participate in that mission and process some of the images. So there's a lot of raw data that you can take every day. Anybody can take that data and process it. But with James Webb, I haven't really heard of an official sort of citizen science side of it yet. And I don't know if that's because they're initially they're so fixated on the targets that they want to, at the very minimum, to make sure that we can at least get some science out of it. These are the key questions we want to try to answer. So I think that part of it, probably the data is going to stay with them for a while. But I guess I don't really know the answer to that, but I would guess that there would have to be eventually some kind of citizen science type portal that we're going to be able to take a look at the data.
Cool. Jeff asks, given that the gold reflecting layer is only 1,000 atoms thick, do we expect degradation over time due to cosmic rays?
There's probably will be, but the thing so there's that, but the thing that I was wondering about was micrometeorites, right? There's a lot of junk out there, and some of the technical stuff that I read, the beryllium is so tough that apparently, even if there are little dings here and there in the gold, it's not going to make that much of a difference. If there's a big object, I think that's a horse of a different color, right? That's what if something goes through the sun shield, for example? So I would assume that there would be degradation, just like there would be even the solar panels are going to degrade over time. But the mission is the primary mission is 5 years, and they're hoping to get 10 years. So, from a degradation standpoint, I assume that some, well, for one thing, the fuel, the earlier question was about the fuel. There's enough fuel on board for 11 years. So eventually the thing's going to run out of fuel and they won't be able to have as much maneuverability as they need. So I think gold is actually pretty tough, even though that's a thin layer. So I expect that it's, I don't think they would have selected something that's going to degrade quickly. I guess let me just say it that way.
That's great. Any other questions? So,
yes.
Given that, go ahead, Stephen.
I was wondering that each of the 18 individual sections, are they flat surface or they parabolic?
I believe they're mostly flat, but they are. Each one was designed for the position where it's going to be placed, so they're not actually all the same. However, being able to maneuver on the backside with the actuators and so forth, they do have some movement that way. So I think that there was careful consideration about where an individual segment would be placed. And so actually, now that I'm thinking more about it, I guess that would actually make a difference. So they're not all the same, right? I don't think they could all be the same, just because there is somewhat of a curvature there.
Yeah, they have to focus on the secondary.
Exactly. Yes. Yep. Good point. Yep.
Yeah. And also, I think beryllium is a toxic metal. Was there much problem milling and polishing the beryllium?
I read that one of the first times they used beryllium was in the Spitzer Space Telescope. So I think that there's probably I don't know technically, I don't know the real answer to that, but I would say that because of that selection, that was a pretty difficult decision to make, right? Because you need some properties that are kind of in conflict with each other. You need something like super strong, but it has to be super light because of the liftoff capabilities or the problems that has. So it's I haven't really heard anything about toxic and if anything's going to leach. Possibly because it's out in like super cold conditions, maybe that's going to make a difference.
Yeah, I was just wondering in the industrial, the terrestrial manufacturing of it.
Well, a lot of things are done in inside of tanks by enclosed things, so if things outgas, right, they can take from a safety standpoint. So I assume that a lot of the safety stuff. Yeah, good point though. Yep.
Okay.
I was reading where beryllium is machined on Earth. It is used. It's pretty expensive stuff. It runs from $600 to $7 a pound. $600 to $800 a pound prior to machining.
Holy cow! Well, it's probably made a little bit of a dent in the $8 billion that they spent on this telescope, right?
Yeah.
When you think about parts.
46 pounds a segment. We can sort of figure that out.
Right? Yeah. Don't drop that sucker, right? Man, be careful, everybody.
Nick asks, what's the definition of a cycle one? How long of a lifespan?
Oh, the cycle one, you're talking about the observing cycle one?
I think that's what he's referring to.
Okay. That is that first cycle is the 6-month cycle.
Okay.
So in the beginning of that first 6-month cycle, they're going to be doing again high priority things to try to address those the best they can. Try to address those 4 primary science goals. So I think there's a lot of the selection of those individual items that they're going to be looking at. They got a lot of experience with Hubble, right? And even with Spitzer, all the space telescopes. So you get a certain understanding of, okay, boy, we really have to prepare. We've got this much time between, the thing is moving through space, right? It's tagging along with Earth. on our journey around the sun all year. So it's moving through space. So you have to really, talk about attention to detail and scheduling. You have to really think ahead and know that, boy, you know what, in 3 months I'm going to be here, and I better let me look at those targets that are in that area, and let's schedule that one. Let's schedule that one. So anyway, that first cycle one is 6 months.
Thanks. That's what I was wondering.
Yep.
Mark asked, why was Guyana chosen as the launch site?
Primarily, it was the rocket. The Ariane 5 is a heavy lift rocket, and they knew that the telescope was, it's not light. It's something like 14,000. I think it's 14,300. I think was the last number I saw, pounds at liftoff time. So you can't, you sort of process of elimination. What is it that can actually has that lifting capability? And the European Space Agency, the agencies that, so ESA and the Canadian Space Agency and all the other folks that are involved in this, that was actually ESA's contribution to the project. So, I think some of the cost of, it's not cheap to shoot a rocket up to, build it basically. So I think primarily it was the launch and the reliability as well, right? This is a one-of-a-kind spacecraft. This is not something that, we have a spare. There's no spare for this. It's so unique. So you have to get some kind of a rocket that's going to be reliable, has a good track record, and the Ariane 5 is one of those rockets. So that's, we're kind of used to launching things from the U.S., but that's a good place, and that's a good rocket. They've got a really good track record.
But was it also something with they wanted an equatorial launch?
Well, that could be part of it, right? I mean, that's part of the beauty of being at the in Florida, right? You get that extra free ride there from from the spinning Earth. So that might have had something to do with it, but I haven't really read anything about that. But that's an interesting question. I think I'm going to look that up. It's entirely possible. But when you have X number, a finite number of launch vehicles, right? You have to choose carefully, and they were pretty good about anticipating how much things were going to weigh and where, how do you balance the telescope when you fold it all up? You can't be, think about, it's real heavy on one side but not on the other. So there's a lot of considerations in that.
Jeff asks, how deep in our galaxy will the James Webb Telescope be able to study evolving planetary systems, check for water and habitable zones and such?
Well, I guess because we're going to be able to look back so far, we're going to actually go out way beyond our galaxy. So I guess I don't quite know how to answer that question, because the sensitivity of the instruments is such that depending on what you're looking for, you're going to know whether it's a far, far away object and therefore very dim versus, it's pretty close, like it's within our galaxy, for example, although our galaxy's big. So I would guess that, other than things blocking your way, like, you can't go right through the center of our galaxy and, peer through to the other side of a black hole kind of thing. But I would think that we should be able to take a look at our own galaxy just in general. But like TRAPPIST, that's in our galaxy, but it's pretty close, right? It's pretty close to us. I think it's one of the closest exoplanet systems.
It almost, in order to get the element signatures, you have to be fairly close, or at least have some kind of resolution to see the absorption lines. So. Mark High here says he's kind of surprised that SpaceX didn't develop a rocket that could be used. Although SpaceX is mostly orbital and suborbital stuff. It's not. They're not in it other than his car.
Well, don't forget about Starship, right? They're in Boca Chica, Texas right now. Yeah. They've got another rocket out on their launch pad, one of their test rockets. So
you talk about reliability. Didn't one just crash for you?
Yes, it did. Yes, it absolutely did. Yeah, it was quite spectacular. It was much better than the first crash. It was really a good one. Yeah.
Dave Bishop says TRAPPIST-1 system is 39 light years away. So.
Ooh, okay.
In relative terms, fairly close.
Mm-hmm. Yep, just kind of a stone's throw, huh?
All right. Any other questions? Well, Carol, thank you so much. We appreciate your coming to visit with us this evening.
Oh, my pleasure. Thank you. Thanks for the invitation.
We got a lot of information on James Webb, and we'll send the Mohawk Valley Astronomical Society our cross references for meetings. So maybe we'll see you at one of our meetings again.
Oh, that would be cool.
Yes. So yeah.
Yeah. Okay. Sounds like a plan. Good.
Cool.
Thank you.
Cool. Thanks, Carol. Anything else? I've got a lot of people thanking you, thanks you. So thanks so much.
Pleasure.
Very interesting talk. All right, folks. Feel free to chat if you'd like. You can bring your camera on and shoot the breeze. We don't get together that often. I can't take you to Applebee's or anywhere else for wings and a drink. So. Welcome, everyone. It's good to see you guys. Good to see me. See, you can see me. Applebee's would be nice, and a nice draft beer. So I'm going to try to. I want to try to do another star party, and I was looking at the January Sky and Telescope had a lot of nice targets of groups of galaxies, and I think that might be a good theme to try to get to do a star party with, is some groups of galaxies. Because it's interesting, you can find the brighter ones and then see if you can share find the ones that are next to them. Hey Vicki, good to see you. I can't hear you. You don't have any sound, but that's okay. It's still good to see you. So we have an open house next weekend. How many people are rooting for Tom Brady on Sunday? I could do a poll. Let's see. Start a poll. Let's see. All right, so if you choose A, you're choosing the Kansas City Chiefs. If you choose B, you're choosing the Tampa Bay Buccaneers with Tom Brady. Oops, what am I doing here? Oh, I lost my poll. Crap. My poll. Yeah, I'm real good at this leading the thing here. I can't find my poll. Here's the poll. Tampa Bay Bucks. Yes, Bill. The Tampa Bay Bucks. I can't find my poll. Where's my poll? I lost it. I can't believe I lost the poll. I don't know how you do that. I'll try it again. Here we go. All right, I'll try it again. I'm sorry. Now you got a choice: Tampa Bay or Kansas City. Yes, I can't close the panel, otherwise I lose my poll. So I'll leave the poll up for a few seconds and then I'll publish the results. I personally, I thought I'd seen enough of Tom Brady in Super Bowls. But of course, Tom Brady hasn't seen enough of Tom Brady in Super Bowls, which is why he went to Tampa Bay to try to get into another one. So it looks like, let's look at coming in. I got probably a little over half of everybody's responded. Not everybody will respond, I'm sure. All right, here's what I got. I got Kansas City 11, Tampa Bay 6th. So 39% to 21%. Not everybody voted. But I think I'll be rooting for Kansas City, although it could be that Patrick Mahomes will be the next greatest of all time, as he's 2 Super Bowls in a row. That'd be pretty amazing. Anyways, everybody wants to hang on. Who's got an astronomy story they want to share? Or any story? Pitchers and catchers. Somebody's waiting for baseball. It should be like this month, right? For pitchers and catchers for baseball. Of course, they just finished too, right? 10 days. 10 days, pitchers and catchers. There you go. Tom is playing his 150th Super Bowl, yeah. He's going to come out there in a wheelchair and start throwing passes all over the field. So the last time, does anybody remember the last time the Bills played the Chiefs in a playoff game? Who the quarterback was for the Chiefs? It was another very famous quarterback. Anybody know that? It's real astronomy related. Not at all. It was Joe Montana. When Joe retired from the San Francisco 49ers, he played a year or two, might have been a couple of years at Kansas City as their quarterback. Yeah, so yeah, as Jeff points out, this is his 10th Super Bowl, and this is Super Bowl 55. So he's played in nearly 20% of the Super Bowls. That's quite enough. Anyway, so are we supposed to get a lot of snow I think we're getting a lot of snow on Saturday. Is there any chance that we're going to be able to go outside and see anything? Get snow? I haven't checked the weather.
Actually, I was just checking the weather. This is Dave Bishop.
Yeah.
It turns out that the site is going to be right under a snowbelt band.
Nice.
Including you. Up here
I
in
got a
Oakland,
plow.
we're not going to get a thing. But you're going to get buried.
What I was watching as the temperature dropped, it looks like Sunday night. That Sunday night. By the time it gets into Monday morning, you're in the single digits.
Nice. I guess I'm not going anywhere.
Well, the
Oh,
atmosphere is so much thinner as it starts to
I
solidify.
see 7 degrees Sunday night's a low. But Monday it's going to be clearing up a bit. Yeah, not going to be great. I'm looking at the whole next 10 days is terrible. There was one nice day, one nice night a couple of nights ago, and I didn't plan ahead for it. I was too tired to actually try to do some. If you're going to do observing and it's that cold, use the dome, the big dome, because you got a warm room you can stay in. You just get the scope set up for a few minutes when the cold, then go down and stay warm and move it around wherever you got to go. But I just wasn't up for it. I was too tired to spend much time. If I was going to go, I would have gone for a couple hours. I couldn't have made it a couple of hours. Just too tired.
Mark,
Yes.
I was checking the site cameras, and
Yep.
the driveway was plowed, but the
Yep.
parking area by the garage was not.
Yeah, that's not right. She's supposed to plow that. I noticed that. I noticed that as well. I
Yeah.
also noticed that we don't have, because of the retirement of Adobe Flash, we don't have a video of the combined pictures. So we'll have to talk to Dave about moving that to HTML5.
Hey, did anybody notice the sun pillars last week? There was one in the evening and one in the morning, or let's see, it was like last Saturday evening and then Monday morning on the way to work.
I saw the one on Monday morning. That was pretty cool.
That was really neat. On the 590 North, there's no chance. I don't have a camera with me, and there's no place to pull over. But it was gorgeous.
No, I look right out my front window and I could see the sunrise, and I saw it on Monday morning. That was pretty cool.
Just seeing the sun was nice.
Yes, yes. It just feels so much warmer if you can see even if you don't not out there feeling it. It just feels warmer having the sun out there. Is Doug still here, or did he go? Douglas, he might have gone. Douglas was here earlier. I wanted to if he saw any sunspots. I know he's a big solar observer. How about Bob McGovern? Looks like he's gone too. Vicky, I can't hear you. I'm not getting any audio from you. I see you moving your lips. If you, yeah, I see you got your microphone on, but I don't hear anything. Oh, you saw Steve? Steve Ventris? Oh, cool. I'll be at the planetarium on Sunday. There's 2 shows on Sunday doing, I think, the Hubble. I forgot the name of the show. It goes through the Hubble telescope and shows about 17 minutes of Hubble images on the whole dome, and then a little star show afterwards, and in the sky tonight. So there's 2 shows on Sunday, and I'll be doing them if you want to come into the planetarium. I don't know. I don't think those shows are sold out yet. Saw Steve in the sky. I think it was Steve Ventris. Not Steve. Steve, the atmospheric phenomenon. Oh, that's pretty cool. That's very cool. I have not seen Steve. Very cool. Yeah, where was it? Where'd you see it, Vic? If you use sign language, you could do that too. I don't know sign language. Not the stress phenomenon, yes. What day was that? Well, there weren't too many clear nights, so it had to be one of the clear ones. There was only like 2 clear nights in the last 30 days. It's been really bad. Early in January. Yeah, so yeah, I have it. So what color was it when you saw it? Was it the red? Is it the red or the green stuff? I don't remember now. It's very similar to Aurora. It's pinkish green. That's kind of cool. I think it could be any color, Nick, right? Can it be like any color? But it's that phenomenon, it's straight up and down phenomenon above, almost like above where aurora would be. Dave Bishop's going to set us straight. Steve's are ropey. So they're like ropes, okay? Up and down, twisted, usually just white. Okay. Interesting. So no, Bill, it was not the Strassenberg phenomenon known as Steve. It was the atmospheric phenomenon. Well, green flash. A green flash is tough to see because you need to have a very still horizon in order to see it. And to have a horizon that's that clear all the way out, even over, especially over water, would be probably the best place to see it. It's difficult to find without some kind of air turbulence going on. But yeah, I would love to see the green flash. I have seen zodiacal light. That's the light reflecting off of dust in the solar system that you can catch just before dawn in the spring and or just after sunset in the fall, based on looking at sun reflecting off of that dust back at you. It's kind of cool. January 9th. I imagine Steve is hard to image. You really gotta, it's fairly transient, isn't it? Does it last very long, Vicky? You're still not getting audio from you. "20 minutes, okay. That's a while." It got lighter and fainter. As it went on, kind of weird, like a weird dim cloud and narrow. Interesting. So I wonder, we know it as Steve now. Do we call that Aurora in the past and not realize what it was, or we just didn't see it? So Paula, we have an email group. It's ASRAS Google Groups. If you want to join that group, send an email to Jim Sidewan. Give you his email address and let him know that you want to be okay. Yeah, and so I spelled it wrong too. Anyway, if you see an event going on, and send an email out and let people know. A lot of times we'll notify each other about Aurora when that happens, or something transient happens, a sun pillar or something. Probably not as much with the sun pillar, but Aurora, especially if we know there's Aurora, we'll let people know it's happening right now, because that's a fairly transient thing. And yeah, like Dave did with the space station yesterday. Frank Bobe says there's a wiki for Steve, so you can look it up. If you go to spaceweather.com, you can see when there's an opportunity for Aurora, and follow that around. And the huge halo around the moon, we got a lot of notes out there. So yeah, use that email list if you want to find out about it. That's kind of cool. That the halo around the moon was cool. Peter Blackwood got a really nice picture of that. I think he published it last month. That was kind of cool stuff. If it's ever clear, and we can observe that stuff. Solar ham too. So if you're, is that a radio thing, Michael? Solarham.org. I've never heard of that. Yeah, org doesn't work, so it must be net. I gotta spell it correctly. So Dave reminds us that during the winter, Rochester is the cloudiest place on the planet. It was confirmed a few days ago by our weather. Yeah, I believe it. I believe it. We're in the doldrums. Well, solar ham, that's good to know, Vicki. I just pulled up the site on another window. That's cool stuff. I'll have to save that. It looks like a good site. Coronal holes. All right, I'll check it out. All things solar, solar ham. Bookmarking it now. Yep, there it is. Nice. Thanks, Vic. So I'm looking forward to Rochester Fest. We booked it late in the summer, and it's I don't think it's a new moon, but it allows us to take advantage of any possibility of having a party and having as many people as possible immunized or otherwise, or just be able to gather in some way, shape, or form. And we're going to have a really nice speaker. I've seen Alex Vilipenko. You've all seen Alex Vilipenko talk as a guest for a lot of astronomy shows. I saw him at NEAF about 10 years ago, and he was phenomenal. I mean, it was very, very good talk. And to have him be able to talk for us would be really good. He does a lot with galactic astronomy. I'm trying to think what he did a talk with us about. So some kind of gravitational thing he did at NEAF. I think it was 2011 or 2010, one of those 2 years. Fantastic speaker, very engaging, super nice guy. When you see him, you'll recognize him. And thanks, Dave. I threw that out in passing at a board meeting, like getting Alex Vilipenko to speak. I was joking, and he went out and got him. So that's pretty cool. I don't know if he was at Black Forest. I don't think so. If it was before my time. Yeah, he still wants a speaker's fee. He does. So we'll have to address that at the board meeting. Even though it's virtual, he wants a speaker's fee. It's expensive living in California. Bill has a picture of him from his blowing stuff up in his high school chemistry lab. He always was interested in things that go boom. That's funny. Yeah, so we hope to have a true Rochester Fest. So if you have talks that you're interested in, or talks that you might want to give, we'll entertain those. We're going to plan it like a true Rochester Fest. Hopefully, we can actually make that happen. Yeah, so Bill, you were probably at that same NEAF because you go to NEAF almost every year. I don't remember the blowing things up, things that go boom. I think we maybe right. They might even have that recorded at the NEAF website. Some of those talks they have recorded. I have to reference those. Anyway. All right, I could talk and bore you guys to tears, unless you guys want to start talking. Vicky's trying desperately to talk, but she can't. I know you're trying hard. Nothing.
I am muted myself.
Yeah, you can't shut Vicky up except virtually.
That's a good one.
So funny.
Yes. Alex Filippenko was Dr. Richmond's advisor.
That's right. I do remember that.
In fact, in 1985, I get an email from this guy that I'd been emailing about supernova stuff from my wedge page by the name of Richmond. And he wanted to know what Rochester, New York was like to live in.
Oh, no kidding.
No kidding.
So that's
emailing Dr. Richmond.
You dragged Dr. Richmond here from Berkeley.
Basically, yeah.
Good for you.
Well, because of me, he already knew somebody in town.
That's right. That's right. Looking forward to that. That should be fun.
But yes, he was his PhD advisor. I've actually been in email contact with 3 different people who have worked with Dr. Richmond. And in fact, there is actually a subpage on the site, which is a trip I made to Lick Observatory. And one of Dr. Filippenko's TAs actually invited me up to Lick to do an observing run. And I photographed it and made a talk out of that many years ago.
Oh, that's awesome. That's pretty cool.
Yeah, Frank remembers.
Frank remembers. I don't think I've seen that talk.
Actually,
Maybe
I think
we'll have to
I've
dust
got
that off.
slides.
We'll have to dust that off. Maybe bring it out for Rochester Starfest or something.
That'd be cool for Rochester Starfest. What do you think for Rochester Starfest?
I like that. I'm going to write that down.
It was like 20 years ago now.
That's all right.
But it was still kind of cool. He took us behind the scenes, and he took us down to the tomb of James Lick. James Lick is actually entombed in the pier of the main telescope.
No kidding. I didn't know that.
No kidding. He's right in the pier.
Well, they're not digging him out.
Well, his original idea was to have a pyramid built in downtown San Jose. And he wanted one the same size as Cheops's. But they tucked him out of it and had him build a telescope instead.
Cheops's pyramid? That's a big pyramid.
He was going to build one the size of Cheops's pyramid in downtown San Jose.
Jeez.
That was his plan for his tomb.
Frank says isn't Brashear similarly interred? A different take. Vikings lit the boat on fire and sent you out, didn't they? Isn't that how Vikings did it?
Well, my chicken wings are almost done, and I'm going to talk to you guys later, okay?
Sounds good. Thanks, David. Appreciate it.
Bye-bye.
Bye now. So I got Dave down to talk about Lick Observatory trip.
Mark, can you hear me?
I can hear you.
I just sent you a photo. Take a look at that before you share it.
It may be tricky to share it on a different computer.
An email.
Yeah, I'm looking. Got a picture of yourself and Alex Filippenko?
Yeah, he's a good friend.
Oh, no kidding. Where have you guys been all my life? Hang on a second. Let me see if I can pull it up over here. I'll share that with everybody. Actually, if you have it on your computer, Bob, I can share the screen with you and you can put it up. There, I'll get it down here. There you go. It'll take me a minute to get at it. So talk among yourselves. No, I can't get to my email on this computer. I forgot my password. It's this long one. I'll give you the. Hang on a second. I'll make you the presenter. And then what you do is you'll have a little screen, or you use the plus sign where it says actions, and then you can. It says upload a presentation. Use that. Just upload the picture.
Okay, hang on.
I think I'm unmuted.
Hey, there she is. Can't keep her down for long.
Now we can hear you.
How long did it take? Like, what hour are we in?
It's 141 minutes.
You have to press 0 on your keypad of the phone.
Oh, okay.
How do I share that again, Mark?
So there's a plus sign at the bottom left of that blue section, and then you can upload a presentation and just upload that picture.
Oh, I get it.
And then you'll go to a screen, and then you select it. You click the little check mark in the circle.
Okay, to be uploaded. Okay, hang on.
Bill, I hear that singing in the background too. What is that? It sounds like Mongolian throat singing in the background.
There it is. So there's, what year is this, Bob?
Man, a while back.
I like the goatee. It looks like evil Spock and regular Spock. You got the evil Spock goatee on.
I was a little younger, and of course you could see the what's the cellophane shirt? Yeah,
the cellophane shirt.
Yeah, no, he did a presentation. Trying to remember where, and I was talking to him. So I have a couple of pictures.
Bill Schlein says he has hair, and I don't think he's referring to Alex Filipenko. That's awesome.
Still a receding foreline.
Yes. Well, those of you who don't know who he is, there he is, and that'll be our speaker in August.
I think he was out at Hawaii at the time. He was spending time out there.
That's a fairly Hawaiian looking shirt.
Okay.
Awesome.
Anyways, I thought since you contacted him, I thought I'd share that.
Yeah, that's great. That's great. Cool. All right. Well, it's almost 10 o'clock. Thanks everybody for coming. It's good to shoot the breeze with you guys a little bit. We'll do this again. I hope to have a star party before the next meeting. Next meeting is in March, and we got the guy from Colgate there. And I hope to, in the next few weeks, get out. The next night that is clear, I'll try to find it out in advance so I'm well rested. I'll do a star party, and I'm actually going to I'll see if I can stream it. I'll try to stream first, see if it'll work. And if I know that I can stream, then the next one after that, I will stream the party live so you can join live. And we'll go place to place. That could be a little more tedious because sometimes we get lost in space and we got to find our way back. And you don't see all that stuff when I record it and show it. But it could be more fun to do it together live.
Like
That's
you're
all I
gonna
got.
go to Mendon. You're gonna go to Mendon Palms Park and do a star party.
No. So what I'm going to do, Vic, is I'm going to go to the big dome and use the C14, and I'm going to show you through the camera what we see through the scope live.
Yeah, I watched one of them.
Yeah.
Okay, that sounds good.
Yeah, that'll be fun.
Mm-hmm.
As long as Dr. Smith doesn't join us, it's okay.
Are you going to use the same program as this for that?
So that will be on YouTube.
Oh,
So if I do it live, it'll be on YouTube. But if I have to record it, we'll use this to show the recording.
Okay.
And then we'll go back and forth like this.
All right. Sounds good.
All right, folks. Well, it's good to see you. We had a bunch of people here tonight, so of course there's not much else to do besides watch the news and do this. So shovel the driveway. Thanks, everyone.
Okay.
Have a good night.
Have a good
Enjoy the weekend.
Bye.
Bye, everyone.